Ernest Rutherford's gold foil experiment produced one of the key findings that shaped our current model of what atoms look like. Back in the early 1900s, the most up-to-date model of the atom was the plum pudding model. J.J. Thomson proposed that atoms were spherical clouds of positive charge, with negatively charged particles floating around in it. He compared this to plum pudding, which was a popular dessert at the time, but you can think about it like a chocolate chip cookie. The cookie is positively charged, with negatively charged chocolate chips floating in it. Now, this was just a theory, meaning it was agreed upon by most scientists, but there hadn't been any experimental findings to disprove it. In comes Ernest Rutherford. He did what any good scientist would do, and he put J.J. Thomson's plum pudding model to the test. His experiment consisted of a device that would emit alpha particles, which are comprised of 2 protons and 2 neutrons. Think of these like little tiny sciencey bullets. These would be propelled towards a thin sheet of gold foil, which consists of many gold atoms. The last part of the setup is a screen that detects the alpha particles. If one of the particles hits the screen, then Rutherford would be able to tell where it hit. So here's what he expected would happen. The alpha particles would shoot straight through the atoms in the gold foil and hit the detecting screen directly in front of the emitter. Rutherford said he expected it to be like shooting bullets through a piece of tissue paper. However, the experiment didn't quite go that way. While most of the alpha particles did hit the expected spot on the detector, some of the particles were deflected a little bit and some were deflected a lot. Think about it like shooting a basketball. If it doesn't go straight into the hoop, it'll hit the backboard and bounce right off. In the gold foil experiment, the basketballs are the alpha particles. But what's the backboard? What is causing the alpha particles to be deflected like this? Rutherford concluded 3 things. Number 1, since most alpha particles did not get deflected, an atom must be made up of mostly empty space. Number 2, since some alpha particles were deflected a little bit, then there must be a positively charged mass in the center of the atom, causing the positively charged alpha particles to be repelled and deflected away from the atom. And number 3, since some alpha particles were deflected at very large angles, that central mass that we now call the nucleus must make up the majority of an atom's mass. Based on these 3 conclusions, Rutherford proposed a new atomic model, the nuclear model, given its name because it was the first model to include a nucleus. Rutherford's model included a large, positively charged nucleus that was orbited by electrons, similar to how planets orbit the sun, which is why this model is also referred to as the planetary model. While this may not be the current theory of what an atom looks like, Rutherford's gold foil experiment was instrumental in our understanding of atomic structure.